Hello and welcome to today's mathematics class. For this class, we'll proceed in the study of binomial theorem. Last previous three videos class, we look at the several methods of solving problems under binomial theorem, ranging from the general method, the Pascal's triangle, and the combination method. If you're interested in watching our previous class on how to use those methods, simply check the description of this video, or perhaps you can check our playlist on mathematics. So the video are there, right? So let's look at the other concept under binomial theorem called the binomial expansion for any index. What do I mean by this? If you have watched our previous classes, or if you attend our tutorials classes from the crash for binomial theorem, you'll observe that most of our examples are always positive numbers, right? That if I have something like this, if I have 3x plus 4y all to power 6, expand this, the number are always what? Positive number if you observe closely, right? But mind you, in this condition here now, what if I have, look up, what if I have a term in this way and I have it minus 2? How do I expand this? This is a minus 2. How do you expand this? Or if I have a minus b, then a fraction 3 over 4. How do you expand this? So that becomes what we are trying to discuss here. So when you have any index, right, either fractional index or negative index, how do you expand this? It has changed from just being a positive number alone. So how do you now evaluate something of this nature? How do you do it? So this condition now is applied whenever your power or your index or your degree is negative, right, or is fraction. That because when you apply this concept. Now, to apply this concept, there are two distinct formula I'll be giving you right now. So master the formula. It will help you in solving problems of this nature. The first formula there is giving us 1 plus t to power n equal to 1 plus nt plus n into n minus 1 t squared over 2 factorial plus n into n minus 1 n minus 2 t cubed over 3 factorial plus ... It continues in this pattern. So it becomes your first formula. Whenever the expression is positive, in this case, let's say for instance, I'm having this question now. This is positive. I'll use positive. I'll use this expression. But whenever the expression is negative, what do you use? I'll have the second formula there. Is given as 1 minus t to power n equal to 1 plus nt. Sorry, observe 1 plus this plus, sorry, 1 minus nt. This is tax plus minus plus n into n minus 1 t squared over 2 factorial. What I put here? This is plus minus plus minus n into n minus 1 n minus 2 t cubed over 3 factorial. Observe that these two are the same thing, but the task now is that when it comes to negative, start with plus, minus, and it continues, right? Plus ... It continues this pattern. So let me explain this, please. We call this first term, second term, third term, and what? Fourth term. So they can tell you to expand. Let's say I give me this question now. Expand this question to its fourth term. Fourth term, it means that you have to what? Write out everything to this point. But for your level, you're always asked to write out for fourth term. Maximum fourth term. They can't give you fifth term. The maximum is fourth term. So know that these are the fourth term here. This is first term, second term, third term, and what? Fourth term. So you're always asked to write till fourth term, right? Or perhaps below, or third term, right? But note this formula. They are very important in solving problems of this nature under the concept of binomial theorem. Let's do some example to further explain this concept. Example says that come in. All right, let's do example 1. Example says that find the first fourth term. You can see that find the first fourth term. Find the first fourth. Okay, 4 perhaps. Find the first fourth term. So this is first term, second term, third term, and fourth term. So find the first fourth term of the expansion of the following. So the first one there goes this way. A, I have 1 over 1 minus x. Then B, that's root 1 plus x. And then C, I have 1 all over 1 plus x squared or cube. So we have this particular question here. So how do you possibly evaluate this kind of problem? Well, it says find the first fourth term of the expansion of the following. So how do we get this done? We said let's start with the first one here, right? Then do second one, you do the third one for me, right? So let's do number 1 there. Let's start with A. For question A there, I have 1 all over 1 minus x. We said expand this to what? To the fourth term. So now the task now is that am I going with the first one or the second formula? Check. This is a minus sign here. So of course I'm going with what? The second formula, right? But what's the task? We said this formula are only applied when we have a negative power or degree or index or fractional one. But look at this one now. There's not any power here. So we have to take this one back to what? Indices. So it becomes a problem. It becomes 1 minus x all to power minus 1. This becomes your indices concept, right? So I'm having a negative power. So of course, I'm having negative power here. I should apply these two formulas here. So which one will I go with? I'm having negative here, so I'm going to what? This negative one with this, right? So at this point now, I'll now recall that 1 minus t to power n equal to 1 minus nt plus n into n minus 1 t squared over 2 factorial minus n into n minus 1 n minus 2 t cubed over 3 factorial. Question says that we should expand it to the fourth term. First term, second term, third term, and fourth term. So it says when it comes to negative, start with plus, minus, plus, minus. So I have this one here. So my task now is get the value of n and t. That's all. So what's my n? Therefore, my n is the power, which is what? Minus 1, comma, what's your t? T is equal to what? Observe, I want to get t. My t is quite simple. I'll compare this with this. 1 is 1, minus is minus. Observe, t is x. So my t is x. Why my n is what? Minus 1. So that becomes a concept. So I've got my n as minus 1 and my t as x. So I'll put the value of minus 1, n as minus 1, t as x in this expression, and that's all. So if I expand 1 minus what's t? That's x. All to power n is what? Minus 1. If I expand this expression, I'll have 1 minus what's nt? N is what? Minus 1 times what's t? X. That's for this one. Plus what's n? Minus 1 into minus 1 minus 1. Then what's your t? That's x squared over 2 factorial is 2. Minus what's n? Minus 1 into minus 1 minus 1 into minus 1 minus 2. Then what's t? S cubed over 3 factorial, which is what? 6. Save time. So I have this. Just put your value there. Anywhere you see n, put -1. Anywhere you see t, put x there. So you have this here. So let's simplify this. If I expand 1 minus x to power -1, I will have 1 minus what? Into minus x. -1 times x minus x plus this -1 into -1 is what? -2 x squared over 2 minus this is -1 into -2 into -3 s cubed over 6. Take it step by step, please. From here now, if I proceed from here, if I expand 1 minus x to power -1, I will have 1 minus is plus x. So only 1 plus x plus, observe, minus is plus. 1 times 2 is 2. That's s. That will be 2s squared over 2 minus, this minus is minus here. -2 minus 3 is plus 6. Plus 6 times -1 is -6. So I'll have -6 s cubed over 6. By the way, I can have two sign here this way. So minus times minus will give plus. So I'll have if I expand 1 minus x to power -1, that will give 1 plus x plus this cancel this. That's what? X squared minus is plus 6 cancel 6 is what? S cubed. This becomes my answer after expanding this term here. So I have this as my answer. So it becomes how to solve this particular problem. Let's do number 2 and we end this concept. Welcome back. Let's do example 2 and we'll end this concept, right? So for number 2 there, the question says √1 plus x. By the way, we said this condition is only applied when you have a negative power or a fractional power. Now my text now, if I send the question in this form, I'll try to express this either in terms of negative power or fractional power or index or degree if you want to. So for me now, I can express this one. If I go back to indices, if I have root a, this can be written as what? A raised to power what? Half. Yes, it's indices. Apply this technique here. What do I get there? 1 plus x, or what there? Or to power half. It becomes what? A fractional index or degree or power, if you want to call it. So this becomes a condition of this nature now. So which formula am I applying? I'm applying the first one, the second one. Of course, the first one. Why? Plus is there. I'm going to plus here. So I apply this. So I will recall that we said if I have 1 plus t to power n is equal to 1 plus nt plus n into n minus 1 t squared over 2 factorial plus n into n minus 1 n minus 2 t cubed over 3 factorial. So I have this. So let's proceed to our solving, please. From here now, we said the task is quite simple. Just substitute and we're off. Let's get the value of n and t. We said to get the value of n and t is simple. Compare. 1 is 1, plus is plus, t is x. So my t there is what? X, comma, n is half. So my n is half. That's all. So put t as x here and put n as half here, and you're off. For me, I will have 1 plus, what's t? That's x, or to power what? N, that's half. If I expand this term, what will I have? I will have 1 plus, what's n? N is half, times what's your t? That's x. That's for this one here, plus so plus this plus is this plus here. What's your n? That's half into half minus 1. What's your t? That's s squared over 2. 2 factorial is 2 plus What's your n here? Half. I have half into half minus 1 into half minus 2. What's x here? That's s cubed over 6. So I have this one here. From what I get, if I expand 1 plus x to power half, that will give 1 plus, this gives x over 2. 1 times x is x over this 2 plus half into half minus 1 is what? Minus half. Then what? S squared over 2 over there plus I'll have half. This half here comes down first into half minus 1 is what? Minus half into half minus 2 is what? Minus 3 over 2, right? Then what? S cubed all over 6. So I have this. So from here now, what do we get from here? I'm just trying my best to take it slowly by slowly, step by steps. So I have 1 plus x half equal to 1 plus x over 2 plus, observe please, 1 times minus 1 is of course minus 1 over 2 times 2 will give 4. Then what? X squared over 2, right? So plus, this is the plus sign, plus, this is half into minus is plus. So 1 times 3 is 3 over 2 times 2 is 4. So I have this, then what? S cubed all over 6. So see proceed with our solvings. I'll have 1 plus x all to power half is equal to 1 plus x over 2. Observe please, plus minus is minus, so I'll have a minus sign here. 1 times x squared is x squared over 4, so I have x squared over 4. Mind you, a divided by 2 is here, so divided by 2, that's for this one here. So plus, this is what? Observe, 1 times 3 is 3, 2 times 4 is 8. Observe, there's a division, that's s cubed here, this s cubed. Let me bring it down. 1 times 3 is 3, s cubed is s cubed here, all over 2 times 4 is 8. Mind you, divided by 6 is there. So let's get this done, please. It means that if I expand that value there, this means that if I expand 1 plus x to power half, I will have 1 plus x over 2 minus, observe, I'll change it to times. That becomes x squared over 4 times 1 over 2, right? This is the invisible one here. So you invert 1 over 2 plus, it becomes 3s cubed over 8 times what? 1 over 6. You invert. So there's invisible one here, right? So you invert. So what do I get here? If I expand 1 plus x all to power half, I will have 1 plus x over 2 minus what? X squared over 8, right? Plus what? 3s cubed over 8 times 6 there, I have 48. So it becomes your answer. I can leave it this way, or perhaps I can still break it down. So if I want to break it down, what do we get? So from there, I'll have, if I expand 1 plus x to power half, I will have 1 plus x over 2 minus x squared over 8 plus 3 here 1, 3 here is 16. That becomes s cubed over 16. It becomes my final answer after expanding that particular question, as you can see. So you try doing the last example, and perhaps you can send the answer to my WhatsApp number. I'll reply you if you are wrong or correct. So see you in the next class. Next class, we'll look at how to find the n term of an expansion and also the coefficient in an expansion.